Okay, this is the sample test for Unit 6 Polynomials, and it is only for Pre-Governor School. So make sure you're in Pre-Governor School if you're watching this video. If not, go to the one before it on the playlist. I'm going to be doing things pretty much without a calculator. All right. So let's start out here at the beginning. The directions. Circle whether the given functions have positive or negative leading coefficients, the degree, the number of turning points, and the number of complex zeros with imaginary components. This is just a big fancy way for saying the zeros that have an I in them. On each graph, mark each real zero with an X. All right, so let's get started. First of all, if we're trying to figure out the positive or negative, whether it's the leading coefficient of positive or negative, we want to look at the right side behavior. If the right side is headed down, that means that we're negative. It doesn't matter if we're an even or odd function. If the right side is pointing down, then we're negative. Over here on number 3, the right side is pointing up, so we're positive. All right, let's go to the next thing, the degree. I think the easiest way to find the degree is to count the number of branches. So every time I change, I'm decreasing, and then I'm increasing. That's a separate branch. So far I had 1, 2, 3 branches, means I'm a third degree function. Let's go to number 2. This one has 1, 2 branches, so that's a second degree function. And then number 3 has 1, 2, 3 branches, so that's also a third degree function. The turning points are just the places where we switch from increasing to decreasing, or any local maximums or minimums. So, oops, sorry about that. I've got 1, 2 turns on number 1. On number 2, I only have 1 turn. And on number 3, I also have 1, 2 turns. Typically, the number of turns is 1 less than the degree, but it's a good idea to just count it from the picture. All right, the next thing is the number of zeros with I. We know that if this is a third degree function, then I need to have 3 zeros. The real zeros are where the x-intercepts are. So we want a third degree function to have 3 zeros. Each branch should create its own zero. If the branch doesn't have a real x-intercept, it doesn't hit the x-axis, that means it must be an imaginary x-intercept. So I've got 1, that's going to have an imaginary one. This branch has got to have an imaginary one because it doesn't touch the x-axis. But this third branch, that one touches the x-axis. I was supposed to mark that with an x. So I'm going to put a mark there. I had 2 imaginaries, and I had 1 that was real. Realize for the imaginary zeros, those always have to come in pairs. We know that if a plus bi is a 0, then a minus bi also has to be a 0. That's our rule that conjugates for any complex with imaginary parts there. Okay. Number 2, if I'm counting, I have 1, 2 branches. Neither one of those, sorry, that's not pointy, it's a U shape. Neither one of those touches, so both zeros there are imaginary. There are no real zeros for that. We don't have any x-intercepts. On number 3, my first branch touches right here. My second branch touches at the bottom or the turning point. And my third branch touches in the same place. So I'm only going to have 1 x on the axis there, but I'm not going to have any imaginaries because all 3 of my branches touched. This one was actually a double root because it counted for 2 branches. I can also tell that that's because I had a turning point on my x-intercept. All right. And again, my zeros with I couldn't be imaginary. So my zeros with I couldn't be odd. I can never have 1, 3, or 5. They'll always come in the pairs. All right, let's scroll down and look at 4, 5, and 6. Okay, so on number 4, again, if we're talking about the end behavior, that's going to tell us whether it's a positive or negative leading coefficient. If our function's pointing down on the right, it's negative. If it's pointing up on the right, it's positive. If it's pointing up on the right, it's positive. All right, when we go to do the degree, we're going to count the number of branches. Number 4 has 1, 2, 3, 4 branches, so that's a 4th degree function. Number 5, 1, 2, 3, 4 degrees, 4 branches, so that's a 4th degree function. And number 6 only has 1, 2 branches, so that is a 2nd degree function. The turning points are just where I switch from increasing to decreasing or vice versa. So here I have 1, 2, 3 turns. That should be 1 less than the degree, which it is. On number 5, I have 1, 2, 3 turns. Again, that's 1 less than the degree. On number 6, I only have 1 turn, and that's also 1 less than the degree. All right, I'm going to mark my real zeros with X's, and then I'm going to count how many imaginary ones. So my first branch here has an x-intercept, so that's a real one. My second branch has an x-intercept, so that's a real one. My third branch has an x-intercept, so it's a real 0. And my fourth branch had a real x-intercept. So all 4 of my x-intercepts were real, so that leaves me with none to be imaginary. If I'm a 4th degree function, I have to have 4 zeros. All 4 were real. On number 5, my first branch touches, and my second branch touches. So I now have 2 real zeros. But this third branch and the fourth branch, neither one of those touch, so both of those are going to create an imaginary, and I'm going to have 2 imaginary zeros. If I total them up, I have 1, 2 real and 1, 2 imaginary, adding to my degree of 4. So that looks good. On number 6, I have this 1 touch of the x-axis. Now that touch was for the left branch and for the right branch, making it a double 0 again. So there is no imaginaries for this one. Although there's one root, it has a multiplicity of 2, or it's a repeated root or a double root. However you want to think about that, it still adds to a degree of 2. Okay, on number 7, it says, given the graph of g of x on the right, that's this thing over here, g of x, identify each turning point with an x on the graph. So I'm just marking the turning points with an x. So this is a turning point. I'm going to put a little x there. This is a turning point. I'm going to put a little x there. That's all I need to do is mark any maximums or minimums. All right, number 8 says, given this same graph, I need to identify the x intervals for which g of x is increasing. That means as I go from left to right, I have to be going up. The section where I'm increasing is this piece right here. I'm going to write the coordinates of what my turning points were. 1, 2, 3, 4, 5 to the left, so that's negative 5, 0. This point right here is at x equals negative 2. I don't really care what the y value is for finding increasing, decreasing. I only use my x's. So I'm increasing from negative 5 to negative 2. So I would write that as negative 5 is less than x is less than negative 2. I'm going to write this answer down, and then I'm going to look for it, and here it is. There's only the one piece there. So the other answers do not get used. Okay, number 9 asks you to find the end behavior of this function right here. When I'm dealing with end behavior and I have my polynomial in standard form, the end behavior is when x is really big, positive or negative infinity. So the only thing that really matters is the biggest term, the term of the highest degree. So if I have a negative function, I know I'm going to go down on the right-hand side. If I'm x to the 6th, I know I might have some bumps in here, but that my left side and my right side are both going to go the same direction. So this one, on the right, x is infinity. On the left, y is down. So as x approaches infinity, y approaches negative infinity. That's this answer. And for the left arrow over here, on the left, x is negative infinity, y is down, so y is also negative infinity. And that is as this one. As x approaches negative infinity, y approaches negative infinity. All right. The next one, state the zeros of the following function and give their multiplicity. This is already written in factored form for us, so all we need to do is set each factor equal to 0. When we set x squared equal to 0, we would just have x is 0. I'm also supposed to state the multiplicity. That's the power of the factor. So x equals 0 has a multiplicity of 2. My second factor here is x plus 5. As a 0, that gives me x equals negative 5. There's no exponent up here. If I had to put a power up there, it would be 1. So I can either not state a multiplicity or I can write multiplicity of 1. It doesn't really matter to me. For my last factor, I have x minus 4. So when I set that equal to 0, I get x equals positive 4. That one had a power of 3, so I have to label that factor as having a multiplicity of 3. When you answer these questions, be sure that it's clear which 0 goes with which multiplicity. I should be able to tell that those two go together and these two go together. Great, let's turn the page. All right, number 11. All the zeros of a polynomial are x equals 3, and that has a multiplicity of 2, and x equals negative 1. Part A asks us to write the equation of the polynomial in factored form. It says to write an equation, so I'm going to start with a y equals or a 0 equals or an f of x equals, something like that. If my first 0 is x equals 3, then my first factor will be x minus 3. That had a multiplicity of 2, so it means the factor is squared. My second 0 was at x equals negative 1, so my factor is x plus 1. If I'm just writing this in factored form, I'm finished. I don't need to multiply anything out. Part B asks me to write the equation of the polynomial in standard form. That means I need to have everything multiplied together, and it's going to be written out as x cubed plus more stuff. So let's go ahead and simplify this. I'm going to start out by multiplying x minus 3 times x minus 3 together. Realize I cannot just distribute the exponent. I have to actually FOIL or do area model, multiply these two things together. So when I go to simplify that, my first x minus 3 squared is x squared minus 6x plus 9. Then I'm taking that and I'm multiplying it by the x plus 1 that I had from the start. So I'm going to put x plus 1 down the side. It really doesn't matter which factor you put on which side of your area model here. And then my other factor would now be x squared minus 6x plus 9. And then I'm going to multiply those together. So I've got x cubed minus 6x squared plus 9x plus 1x squared minus 6x and plus 9. Notice I took the time to write the sign of each thing in the area. That'll help you when you go to put stuff together. So my first term is just going to be the x cubed that I had there. For my second term, I have 1x squared minus 6x squared, which is negative 5x squared. For my third term, I have my negative 6x and my positive 9x, which gives me plus 3x. And then my last term, my constant, didn't have anything else with it. It was just a plus 9 on the end. So there's my equation in standard form. All right. Number 12 asks to write a polynomial in factored form that would have the characteristics of the graph below. So it's going to be a polynomial. Since it's a graph, I'm going to start it with a y equals instead of a 0 equals. And then I want to look at each of my zeros. I have a 0 right here, 1, 2, 3, 4, 5, 6, at x equals negative 6. If x equals negative 6 is a 0, then x plus 6 is a factor. I also have a 0 over here at x equals 1, 2, 3, 4, 5. So if I have a 0 at x equals 5, then my factor is going to be x minus 5. Now I have to pay attention. This was a turning point. It wasn't a go-through point like I had at negative 6. So this is actually a double root for a 0 that has a multiplicity of 2. So I'm going to have to put a squared with that factor right there. The last thing we want to be careful of, because sometimes we forget to look for this, is our right end behavior. This is pointing up, so that means we really do have this positive polynomial. If the graph had been flipped over and it had looked like this, we would have had to put a negative in front of our first factor. Okay, number 13 says sketch a polynomial that has real zeros at x equals 4. So I've got to have an x-intercept here at 4. And at x equals negative 3. Now that one has a multiplicity of 2, so this one has to make a U shape where it touches right there, as well as 2 zeros that are complex with imaginary components. So that means I need to have some sort of extra bump. I have to have 2 branches that don't touch my x-axis. It says nothing about whether I'm an even or an odd degree. It doesn't say anything about whether I'm starting up or down. So I can go either way with this. You can start from the left or the right, doesn't matter. If I start down here, I'm going to make a U shape when I get to that first 0. In order to get back to the x-intercept, I've got to turn around. And then somewhere I have to have 2 branches that don't touch. So that's a great example of one that would meet all the qualifications. I also could have started out up top, made a U shape, gone down and crossed, and then had an extra bump. Or, see how much room I have here, I could have made my extra bump in between my 2 zeros. That would have worked as well. Or I could have made my extra bump before I even started. So I could have had an extra bump, come down, touched, and gone around. Any of those types of things were fine. You just have to have the characteristics that this one makes a U shape, this one grows straight through, and somewhere there's an extra bump that doesn't touch the x-axis. All right, number 14 asks us to write the equation of the polynomial graph. On your test, this will be multiple choice, so there will be things to choose from. But I should be looking at this general shape right now and saying I know that has to be an odd-powered function. This is sort of the center or anchor point for my graph. So if it's a cubic, it would normally make a bend going up, and this bend goes down instead, so it's going to be negative. From my center, I went up 1 over 1 in each direction, so I don't have any multipliers. There's nothing stretched by this x cubed, but it does look like I've moved over. How far have I moved to the right? I've moved 3 units to the right. To do that, I put a -3 on the inside, because anything on the inside is always the opposite of what it tells you to. And I've gone down 1, so that would be on the outside. I would have a -1. All right, I should double check that this is in fact a cubic. Don't just assume. If I go over 2, I should go up and down 8, which I do. So I can tell that that follows my cube shape. All right, on number 15, I'm supposed to graph a cubic. So I start out, I want to find my anchor point. I did +3 on the inside, which is going to move my anchor point 3 to the left. So that's my starting point for my graph. When I'm choosing points to make for an x cubed, I know that x cubed makes a bendy shape. 0 cubed is 0, 1 cubed is 1, 2 cubed is 8. So from my anchor point, I go over 1 up 1. I go over 2 up 8. And I also know that when I cube a negative number, it's going to be negative. So rather than go up on the left-hand side, this one's going to go down on the left-hand side. 4, 5, 6, 7, 8. Oops. I put arrows on both ends to show that it keeps going forever. And I've filled my graph completely with any points that would fit. Number 16, I've got an x to the 4th as my parent function. So that's going to make a U shape. My only moving is to move up 2. So I'm going to start out, I'm going to go up 2, and I'm going to put my anchor point there. The other transformations I have a negative out in front, which is going to flip my U shape over. And then I also have this 1/4, which is a stretcher. It's on the outside, so it's going to actually shrink me vertically in 1/4. My normal shape for x to the 4th, 0 to the 4th is 0, 1 to the 4th is 1, 2 to the 4th is 16. I'm going to do another one since I'm shrinking. 3 to the 4th power, that's pretty big. That's 3 times 3, which is 9, times 3 is 27, times 3 is 81. So I don't think this guy's going to fit on there. But then let's go ahead and take a 4th of each of those. So from my anchor point, I'm going to go over 1, and I'm going down a 4th. I can't put perfect points on the graph, but I can kind of ballpark where they go. A 4th of 16, that's a nice number, that's 4. So from my anchor point, I'm going to go over 2, down 4. Oh, by the way, I'm mirroring on the left and the right for this graph because it made a U shape, because whether I plug in a positive or a negative, when I square them or take them to the 4th power, they're going to give me a positive answer, which I then multiplied by the negative and flipped it over. Okay, so if I took a 4th of 81, that's going to be 20 1/4. So it's not going to fit. I'm not going to worry about that one. I'm going to show my U going down. I'm still filling my graph. Notice I'm not making these ends float way out here. This made a U shape. It didn't start to bell out on the sides. I have arrows on both ends to show that it keeps going down forever. All right, now I'm on to division for number 17. So I'm supposed to divide. I'm going to use my area model that I've put up here. If I have the length times the width of a rectangle, it's going to give me the inside, which is the area. So that's length times width equals area. I can rearrange that statement and turn it into a division problem by saying that the area divided by the length is equal to the width. So if I'm doing division, this is going to be my area or my inside. That's my area. The bottom here is going to be my length in this case, or the left of my box. So I'm going to start out, I don't know how long to make the box, I'm just going to make it keep sort of ending. So I've got 2x minus 1 there. And now I'm going to start out by putting my inside inside. My first term is 2x cubed. So I'm just going to put that inside because that's where it belongs. And now I'm going to start to work to figure out what else I know. Well, if this was 2x cubed, then what must have been on top when I multiply this times 2x, it has to give me 2x cubed. So this must have been an x squared. Then if I know that's an x squared times negative 1 is negative 1x squared. That's what would be down here. All right, now I've got to figure out what goes over here in this box. I know that I'm really supposed to have negative 7x squared. Currently, I have negative 1x squared, so I need to put a negative 6x squared so that when I total these two together, I have a complete negative 7x squared. So now that I've done that, I can figure out what must have been on top, because whatever's up here times 2x has to equal negative 6x squared. That means on top, I'd need a minus 3x. Write the sign of that whether it's positive or negative, because otherwise we lose terms. So I've got negative 3x now times negative 1 is positive 3x. Again, I'm writing the sign to keep track of everything. But inside my box up here, I'm supposed to have 11 x's. I have 3 x's. That means I need more. I need 8 more x's to total up to 11 x's. If I know that that is 8x, what number must I have multiplied my 2x by to get 8x? Well, that must have been plus 4. 4 times negative 1 is negative 4. Again, I look back up here, I'm supposed to have positive 5 inside. So if I'm at negative 4, I'm going to have to put positive 9 so that when I combine them, I have a total of positive 5. All right, so notice this 4. I didn't have any x's left. Now when I'm trying to figure out what times this gives me positive 9, well, positive 9 is my remainder. I'm going to write that as positive 9 over 2x minus 1, so that if I took this and I multiplied it by the 2x minus 1, the 2x minus 1s would cancel out and all I'd have left was 9. All right, it says circle your answer, and that's just so that we don't forget what we were really doing here. This is the width or the answer to the division. All right, number 18 is x minus 2 a factor of this polynomial? And explain how you know. There's different ways I can do this. If x minus 2 is a factor, then that means x equals 2 is a 0. So one option would be to plug in 2 and calculate this and see if it's 0. If I had a calculator, I might do that. Another thing is I could find out if x equals 2, 0 is an x-intercept. And if I had a graph, I might do that one. But I don't have either one of those things. So I think what I'm going to do is I'm going to divide and see if it goes in evenly. So if I divide my polynomial by x minus 2, if I don't get a remainder, then I know I'm good. So I have 2x cubed. I start out, put that inside. So what goes on top? What times x gives me 2x cubed? 2x squared. Then 2x squared times negative 2, that's negative 4x squared. Looking at my problem, I'm not supposed to have that. I'm supposed to have positive 8. If I've got negative 4, I'm going to need to put in positive 12x squareds to get rid of my 4 negatives and still have 8 more left. So altogether, that gives me 8x squared. All right, so what number must have been on top? What times x gives me 12x squared? Positive 12x. Positive 12x times negative 2 is negative 24x. And then I'm looking, I'm supposed to have negative 3x. If I've got negative 24x, I have to put in positive 21 to balance out and keep negative 3x. So now I'm figuring out what would have gone on top. That must have been a plus 21. And then 21 times negative 2 is negative, 42. So that's not what I'm supposed to have. So there's a remainder. I don't really care what it is. There's just enough to say there's a remainder. So x minus 2 is not a factor. All right, number 19 here has this polynomial f of x. Realize since this question has part A, B, C, all that stuff down there, all of these questions have to do with this same polynomial. So to start out, I'm supposed to divide it by 3x plus 1. So 3x plus 1 is going on the outside of my area as one of the factors. And then I'm going to put my f of x on the inside. So I've got 3x cubed in there. So what number must have been on top? That must have, what number times 3x is 3x cubed? That's just x squared. X squared times 1 is positive 1x squared. How many x squareds am I supposed to have? I'm supposed to have 7x squareds. I only have 1, so I need 6 more. Okay, sorry about that. Okay, so what number times 3x is 6x squared? That would be a positive 3, oh no, not 3 times 3 does not give me 6. Let me fix that. Let's try 2. 2 times 3 gives me 6. Okay, so 2, and I need an x. 2x times 3x is 6x squared. 2x times 1 is positive 2x. But I'm supposed to have negative 13x. So I have to get rid of these two and then still have 13 more. So that's negative 15x's. And then what times 3x is negative 15x? That would be negative 5. Then negative 5 times 1 is negative 5. And look, that worked out. I was supposed to have negative 5, so there's no remainder out here. The answer to the division is this x squared plus 2x minus 5. All right, so question B says, what is the complete factorization of f of x? So I'm trying to set you up here. We know that if this is the area, that's f of x, then the two factors are what we had outside. So our first factor was that 3x plus 1 that we divided. And our second factor is what we got as the answer to the division, the x squared plus 2x minus 5. Now this said complete factorization, so I want to check, can I factor this some more? Are there two things that multiply to positive 5 and add, multiply to negative 5 and add to positive 2? So I'm multiplying to negative 5x squared, and I'm adding to 2x. Well, when I go to do this, in order to multiply to a negative, one has to be negative and one has to be positive. They both have to have x's with them. How can I multiply to 5? The only way to do that is 1 times 5. I would need the 5 to be positive to make it positive when I add it together. This is not going to work. This part is prime. The whole problem's not prime, though. This is just the complete factorization. I'm done. I can't factor that anymore. But I can find more roots to this thing. What are the roots of f of x? Well, to find the roots, I set the factor equal to 0. So if I set 3x plus 1 equal to 0, I would subtract 1 to move that over, and then divide 3 to move the 3 over, and I'd have x is negative 1/3. Now, just because this was prime doesn't mean I can't still solve it. I'm just going to have to use the quadratic formula to solve it. So I have the formula there. Oops. I've got x equals the opposite of b, so negative 2, plus or minus the square root of b squared, so 2 squared minus 4ac, and all that was underneath the square root, all over 2a. All right, so let's do some simplifying here. I have Negative 2 plus or minus, when I do 2 squared, that's 4. Then I have minus 4 times 1 times minus 5, which is plus 20, positive 20. And that was all over 2. So now I have negative 2 plus or minus the square root of 24 all over 2. I do need to simplify that answer. So I'm going to try to simplify the square root of 24. 24 is 4 times 6. So I can take a 2 out from underneath. I'm just going all over here, sorry. So I have 2 plus or minus. The 2 gets taken out. I still have 6 left inside. And that was all over 2. And then last, I can reduce one more step. Since all of these guys are divisible by 2, I can take a 2 out of them, and I'll have negative 1 plus or minus. This 2 reduces out, so all I have left is the square root of 6. And then this 2 would be turning into a 1, so I don't need to write the denominator. I just have 1 plus or minus the square root of 6. If his original problem was x cubed, and then I should have 3 answers. I have negative 1/3, I have 1 plus the square root of 6, and I have 1 minus the square root of 6. So that's 3 answers, just like I was supposed to have. Question D asks me, what are the solutions to this exact same f of x equals 0? Well, I need to know that roots and solutions and zeros, that's all the same thing. So I'm just going to list out the same answers that I already found. I've got negative 1/3. I have negative 1 plus the square root of 6, and I have negative 1 minus the square root of 6. I could have left them as a plus or minus. It doesn't really matter to me. I'm just listing them out. So for either of these questions, I could have written it as a set of 3 answers, or I could have written individual answers and circled them. Doesn't really matter. Let's see if there's anything else on the bottom of this page. Nope, we're done. Let's move on to the next one. Oh, I hit twice. All right, we're factoring now. When I'm looking at just factoring and I don't have a calculator, first thing I'm always going to look for is a GCF. They have nothing in common. Then I'm going to count the number of terms. This has 2 terms. If I have 2 terms, the first thing I check for is it a difference of squares? And these aren't squares, they're cubes. So I need to know my formula for cubes. A cubed minus b cubed. The first factor is a minus b. This has the same sign as the original problem. And then in my second factor, I'm going to have the opposite sign, and the last sign is always positive. And as far as the terms in there, I square the first thing, so that's a. I multiply them together, so that's ab. And then I square the second thing, so that's b squared. So for me, if I have 8x cubed, the cubed root of 8x cubed is 2x. So in my first factor here, I have a 2x. My second thing was a 27. The cubed root of 27 is 3, so my second term is a 3. My original problem was a minus, and I keep the same sign for the first factor. The signs for the second factor, it goes same, opposite, positive. Now I'm going to take my first term here, my 2x, and I'm going to square it. When I square 2x, I have to square the 2 to make it a 4, and square the x to make it an x squared. My middle term is the product of these two. When I multiply those two together, 2x times 3 is 6x. Notice this negative in here? I'm not using that right now. That was part of the formula. My 2x and my 3 are both always positive. All right, then for the last term, I'm squaring my last term. So 3 squared is 9. And that's it, I'm done. The last thing I do when I factor is always check to be sure I can't factor any factors anymore. So 2x minus 3 is done. I can't factor anything else out of that. The 4x squared plus 6x plus 9, I could check that. Can I find 2 things that multiply to 36 and add to 6? No, I can't, so that one's finished. All right, number 21, again, I start out and I look, is it a difference of squares? No, it's 2 terms. There's no GCF. My option is difference of cubes. It's a plus. My first term was x cubed. The cubed root of x cubed is x. My second term was 64y cubed. The cubed root of 64 is 4. The cubed root of y cubed is y. When I go to make my second factor, whatever sign I had in the problem, the first sign was the same. The next one was the opposite, and the last one's always positive. Now I just need to follow my pattern. I square the first thing, that's x squared. Then I get the product of the two, so that's x times 4y, which is 4xy. And then I square the last thing. 4 squared is 16, y squared is y squared. Okay, number 22 is to completely factor this problem. So I start out and I look at it and I say, is there a GCF? No, there's nothing they all have in common. It has 3 terms, so to do 3 terms, I prefer to factor with my area model where I draw the box. I've got to be sure that this follows the pattern where if this one, the exponent is double from the middle term, and it does follow that pattern. So my 9x to the 4th is going to go here. I know that if this is x squared, both of these guys are going to have to be x squared. So when I add them together, I have to get negative 37x squared. And when I multiply them together, I have to get x to the 4th. So that worked great. My plus 4 is going down here on the bottom. So if I multiply those two together, my 9x to the 4th and my 4, that means I'm multiplying to 36x to the 4th. And then I have to add to the middle term, so I'm adding to negative 37x squared. So in order to multiply to a positive and add to a negative, both of these have to be negatives. Again, they both have to be x squareds. So what two numbers multiply to 36 and add to 37? That is negative 36 and negative 1. All right, now I look at my top row here, and I take the GCF out of those. So my number part is 9, and then they both have an x squared. So I'm going to take out 9x squared. On top, what times 9x squared gives me 9x to the 4th? Well, that's x squared. What times 9x squared gives me negative 36x squared? That's negative 4. What times x squared, gives me negative 1x squared? That will be a negative 1. And then my check, does negative 1 times negative 4 equal positive 4? Yes, it does. So my two factors are here and here. I have 9x squared minus 1 and x squared minus 4. My final step in factoring completely is making sure I can't factor any factors more. 9x squared plus 1, it has 2 terms. That means it could be a difference of squares, which this one is. 9 is a perfect square, x squared is a perfect square, and 1 is a perfect square. And they have a minus in the middle, which means it's a difference. So when I square root, I've got 3x minus 1 times 3x plus 1. All right, now for my second factor, x squared minus 4. Again, those are both perfect squares. So I have x minus 2 times x plus 2. So I had a difference of squares for both of them, and both could be factored some more. If one could be factored and one couldn't, I'd just copy the second one down and factor the one that I could factor. All right, now I have a review question here for 23 and 24. I've got g of x and f of x. Let's put that down a little bit. My g of x is x squared minus 3x, and my f of x is 4x plus 5. I'm supposed to find f of g of x. So what does this mean? This means f is on the outside because f came first, and g is on the inside because g came second. And I'm not plugging anything in for x, I'm leaving it g of x. So my f function was 4x plus 5, except instead of x, my inside is going to be the whole thing g of x. This entire thing, x squared minus 3x. Now I need to simplify that, so I'm going to distribute my 4. So I'd have 4x squared minus 12x, and then the plus 5 that was down there on the end. So looking through my answers, 4x squared minus 12x plus 5. Looks good. All right, on number 24, I have f of g of negative 2. So in this one, I'm going to plug a negative 2 into g of x. So starting with my g of x function, my g of x was x squared minus 3x, except instead of x for all of those, I'm going to write negative 2. I have to plug it in for every single x in the problem. So now I need to simplify this. Negative 2, the quantity squared, negative 2 times negative 2 is positive 4. Negative 3 times negative 2 is positive 6. 4 plus 6 is 10. So g of negative 2 is 10. Now I'm going to take that 10 and I'm going to plug it in to f. So f was 4x plus 5, and I'm going to plug in 10 for my x. And I'm going to simplify that. 4 times 10 is 40, and 40 plus 5 is 45. And that was answer choice A. All right, so that finished up the no calculator part of the test. Now we're on to the part of the test with the calculator. So I popped up the calculator here. Number 25 says, use your calculator to find the coordinates of any turning points. Those are any maximums or minimums of this cubic function. I know when I graph an x cubed that it should look something like this. It should have 2 bends in it if it's a third degree function. I'm going to put that into my y equals over here, and then I'm going to try a standard window and hope that looks good. So I'm going to go to zoom 6 for standard, and I look at my picture. Now, I can't see any top to this peak over here, so I'm just going to zoom out maybe a little, or I could change my view window, either way. But now I have, oh, that doesn't really look so pretty. Let me go back to my window instead. My x's from negative 10 to 10. Those seemed like they were going to be okay. My y's from negative 10 to 10. My negative 10 on the bottom was fine, but I think rather than change that y min, I'm just going to change this y max. Probably doesn't even need to go up to quite 40. It looked like it was going to come pretty soon, so I'm going to change that to 20. So I've just played a little with the window, and now I have the shape I need, and I can calculate this maximum and this minimum. So I go to second calc. I want to find the maximum, which is number 4. The left bound, I need to go to the left of the peak, which my calculator just somewhere over here on the left, hit enter. The right bound, I need to go somewhere over here on the right of the peak and hit enter. And for the guess, I go as close to the peak as I can and hit enter. And it tells me my maximum is at 0.333 and y is 12.481. So I'm going to just write that down over here. 0.333. I'm going to give truncate to 3 places after the decimal. So I'll just stop writing down after 3 places. I will not round. And my y was 12.481. That was a max. It didn't ask me. It just said find the turning points. Be sure you pick a point on the left and a point on the right when you're finding these, or you'll get the wrong answer. Second calc the minimum. That's number 3. So I need the left of my minimum, which is going to be somewhere down here in the bottom. Hit enter. Go to the right bound. So I need to go over to the right of my minimum. Hit enter. And then for my guess, I go as close to the minimum as I can and hit enter. So for this one, the value that I got was 2.99999. If you want to call that 3, that's fine. I think this point, if you really found it, would be 3.3. If you had written 2.999, that's fine. My calculator has some limitations of just how accurate it can get. If I wanted to confirm that this point really was at 3, the best thing I could do would be to go to trace and type in 3. And look, 3.3 is the exact value of the point. All right, number 26. Number 26 says, given this function for y, completely factor it. Well, if I look at this problem right here, I have no idea how to factor that. It's 4 terms. I could try to do an area model, but honestly, I've got my calculator. Let's see what the graph looks like. So I'm going to go to my y equal. I've got x cubed minus x squared minus 5x. And minus 3. I'm going to go back to, whoops, that's minus 32. I'm going to go back to my standard window. So I'm going to go to a zoom 6 again. Now I can see it looks like I have an x-intercept right here at -1. If I want to tell that that's exactly where it is, probably the easiest thing to do, I went to second trace, and now I'm going to just type in -1. And it tells me, yes, at -1, 0, that's a 0. So this problem asked me to completely factor and find all the zeros. So I'm going to write that down as a 0. X equals -1. It didn't ask me, but I know this has a multiplicity of 2 because I know this 0 is a turning point. Since it touches for that branch and that branch, I'm using the same 0 twice. So if I'm writing my factors for y, I would have x plus 1 with a squared because that factor is a factor twice. Now I've got another 0 over here. It looks like it's at 3. I'm going to type 3 and it goes over, and 3, 0 is a nice, neat 0. So if x equals 3 is a 0, then x minus 3 is a factor. And I've just used my calculator to both factor and find the zeros for very little work right there. Okay, work efficiently, and that's the fastest way to do this one. All right, number 27. I'm going to hope that this one works out just like the last one did. I don't think it will, though. All right, let me check. Okay, so I've typed in that function right there for g of x, and I'm in the standard window, so I'm going to graph it. And I know that this should make some sort of cubic shape, so it should do something like this. Whoops, sorry, my pen's not writing. It looks like I have one x-intercept over here. I can't even tell exactly where that is. And then I have something going on down here. Let me zoom out for a second and see if I can find my whole picture. Zoom out. And it looks like this thing is just coming down here, maybe doing a little bend in there, but my only x-intercept is that one I had. I'm going to go back to my zoom 6 because that was a much prettier picture. So it looks like it's at about 1.5. I could trace and then I could guess, does 1.5 work? And I can see, yes, it is 1.5. But if you didn't know that, if you wanted to find the 0 from the picture, the best way for us to do that is to go into y2 and put y2 equals 0. And now I can just find, when I graph 0, it's just going to graph the x-intercept. I'm sorry, the x-axis. So I can't see it graph. But I want to find where does this function cross the x-axis. So that means I need to calculate the intersection of y1 and y2. For the first curve, I need to move my blinker over here. I don't see my blinker. There it is. Get close to where they cross and hit enter for the first curve, enter for the second curve, and enter for the guess. And it tells me that they did cross at x equals 1.5. So I don't know whether it made a bend down here or if it just did a regular cubic shape. It doesn't matter. This is my only x-intercept. So my only real solution right here is going to be x equals 1.5. If x equals 1.5 is a solution, if I'm working backwards, that's 3/2. So if x equals 3/2, and I want to set this as a factor that I set equal to 0, I would move the 2 over by multiplying it, and I would move the 3 over by subtracting it. So that means that 2x minus 3 must have been a factor. So how can I figure out the other factor, the quadratic, that's not going to have nice answers? Well, I can divide out my 2x minus 3 from my original problem. Okay, so I'm dividing 2x cubed is going to go in my first box. So what times 2x gives me 2x squared? X squared times 2x gives me 2x cubed. X squared times -3 is -3x squared. How many x squareds am I supposed to have? I'm supposed to have +1. So I need to put +4 in there so that I have a total combined of x squareds of +1. Now on top, what times 2x gives me 4x squared? +2x times 2x gives me 4x squared. On the bottom, 2x times -3 is -6x. I'm supposed to have +6x. So I have to do +12x. So what must have been on top? +6 times +2x gives me 12x. On the bottom, 6 times -3 is -18. And fortunately, that's what I was supposed to have. If I didn't, that would mean I messed up before, because 2x minus 3 is supposed to be a factor. And in order for 2x minus 3 to be a factor, when I divide, I can't have a remainder. So I'm going to put my g of x equals. I've got 2x minus 3, and my other factor is this up here. x squared plus 2x plus 6. I can try to factor that x squared plus 2x plus 6, but it's not going to factor. I know that because I didn't have any nice x-intercepts over here. So I'm guessing this thing's probably going to have some imaginary zeros. How are we going to find those imaginary zeros to answer for the solutions in part B? I'm going to have to do the quadratic formula on this one. I know my first factor was this x equals 3/2 that I already got. Doing the quadratic formula on the second factor, I have the opposite of b, so -2, plus or minus the square root of b squared minus 4ac all over 2a. Okay, so now I'm going to start simplifying. I had a -2 plus or minus, when I square the 2, that's a 4. And then I have -4 times 1 times 6 is -24. So now I have on the bottom a 2. Okay, let's put that together some more. On the top here, I have 4 minus 24. So that's the square root of -20. On the bottom, I have my 2. I can't leave that -20 underneath the square root. So if I'm going to try to simplify my -20, when I factor that down, 20 is 4 times 5. So I can take a 2 out. -2 plus or minus, I can take a 2 out. I have to take this negative out also and call that an I. And then I still have my 5 left inside. And then on the bottom of the fraction, I would have a 2. My final step of simplifying here, I have all of these are divisible by 2. So that would be a -1 plus or minus. These 2's would reduce out, and I have I square root of 5. Oh my goodness, sorry, that's not the prettiest. 5. So let me come back here and rewrite my answers all together. How about x equals 3/2 or 1.5, I don't care how you write it. And then the other two, -1 plus and minus I square root of 5. My original problem was x cubed, and I have 1, 2, 3 answers when I count the plus and the minus. All right, so the rest of the problems here are applications, and I might have to do them in a separate video. I'll try and piece them together at the end, but this is getting pretty long.